Okay guys, welcome back. When you open a file like main.go for the first time, something becomes obvious immediately. The Go compiler is opinionated. It might start complaining before you've even finished typing. But don't worry, this is not a flaw. This is one of the Go's biggest strengths. The compiler enforces strict rules to keep your code clean, predictable, and safe. If you work with these rules instead of fighting them, the compiler becomes your best ally. Next topic, the entry point, package main, and func main. Let's go to the code editor. Every executable Go program starts in exactly the same place. It does not matter whether you are writing a tiny script or a massive backend system. Execution always begins in one function inside one package. So first, you need to declare package main on the top. You can name other packages anything you want, like utils, database, and layers, but Go compiler specifically looks for package main. It means for Go, this code should be compiled into executable binary. Rule 2 is func main. You must also define this exact function, func main. This is the non-negotiable entry point of your program. No parameters, no return values, no variations. If it is missing, your program will not run. We can verify it. I will remove the func main and I will type go run dot. You see function main is undeclared in the main package. If I put it back and run go run dot, you see no error. Also, if you remove package main and you try run it, you see expected package found func. So I didn't lie, it's necessary. We run our code and we want to see something in the console. So we will be writing hello world example. To print text to the console in Go, we use the standard library. Go uses the import keyword to bring in functionality. For printing text, we need the fmt package. So let's write it, import fmt. And here is an important compiler rule. Go doesn't allow unused imports. We can also verify it. Let's run the code. And you see fmt imported and not used. So it doesn't work. If you import fmt but never use it, your program will fail to compile. This might feel strict at first, but it keeps your code base clean and minimal. No dead dependencies, no hidden clutter. And now we can use the full example. Let's type fmt. For example, we can use println function, and the text can be hello world or hello YouTube. It doesn't matter, you can type anything you want. And if you run it, go run dot, you see hello YouTube. Go run compiles your code on the fly and executes it right away. Perfect for development. The next topic is package structure. It's the one-way door. As your application grows, the package main will import other packages, database logic, routing, business rules. But there is a strict architectural rule you must understand. This is a one-way door. Package main can import other packages. Other packages cannot import package main. And package main exists only to wire the application together, execute the program via func main. It should never contain reusable logic. This rule forces clean architecture by design. The next one is building binaries, so creating a snapshot. While Go run is great for development, production systems rely on compiled binaries. So we can use go build. Let's type go build and output main, and we will specify main go. If you run it, you see there is a new file main, and now we can type main. I am on Windows, it won't work. I need to type main.exe. Now I can type main.exe and you see hello YouTube. If you are on Windows, you need to type main.exe. If you are on Linux or Mac, you need to type main without exe. The snapshot trap. Here is a critical concept many beginners misunderstand. A binary is a snapshot in time of your code. If you change this line, hello YouTube, to hello Thomas, for example, and you run main.exe, it still prints hello YouTube. It means it runs the old binary. The question is why? Because go run main.go compiles current code, then runs it, and main or main.exe runs the code as it existed at build time. So it's different. Any code change requires rebuilding the binary. So you need to run it again, go build, and now you see the difference. It prints hello Thomas. Summary: Go is strict by design, and that strictness pays off. The compiler enforces structure, clarity, and correctness from day one. Once you internalize these rules, Go becomes one of the most predictable and production-friendly languages you can work with. If this breakdown helped you understand how Go really works under the hood, consider subscribing, and see you in the next video.